So what we have here is a GM dealership that was modeled in Revit, and so our consultants wasn't using Revit, and quite often your structural engineer won't be necessarily using Revit, so you can see it here. Let me get you just a color version of it. Okay, so there you go. Now, this building was kind of what it looked like before. It was just a very round shape at the front. There were some existing glulam beams, and so we tore out the old curtain wall, expanded the showroom, and here's the revised version. So that's a good example of how phasing was worked, to model an existing building and then add onto it. So here you can see all the existing stuff in the background that's in gray. Now, the structural engineer provided us with their design, and we modeled it in Revit. So we have a mix of the existing wood frame construction, which you folks can see here, some of these glulam beams, and then you can see the added steel structure that was added around the front of the showroom, and then there was a drive-through service that was added as well. So you can see the open web steel joists, steel columns, and curbs that were added. Now, even as the architectural consultant, this was by no means an onerous task for us to do. And as you probably know, the biggest conflicts that happen on site are between your structure and your mechanical systems. And this is no different. So in this project, you folks can see you've got these big glulam beams here that were being borne on the end of this new W-shaped beam at the front of the showroom. And so the problem arose where the mechanical engineer wanted to put a big, huge supply duct in between these two glulam beams and bring it down to the front of the showroom, and then bring air supply in a bulkhead around the perimeter. It was quite deep. It was about 18 inches deep. And so because we had modeled this, we were able to, when we were looking at the mechanical engineer's drawings, we were able to look at a section here, and you can see this section never made it onto a sheet. We just used this section for exploratory purposes to determine here at the front that we weren't going to have enough room to get the mechanical engineer's duct above our steel beam and under the joists that the structural engineer had specified for this application. So the glulam beams, you don't see them, they're buried behind a concrete, or not a concrete, there's a gypsum furring wall here that's obscuring the glulam beam that's sitting behind you. So by the time this duct came down, there was no way it was going to clear. So we had a quick call with the mechanical engineer, and we said, you need to flatten your duct and make it wider so it can fit over top of the beam. So there's a good chance it might not have been caught until they were all on site and someone's looking up at the space and going, hey, this doesn't work. So we saved ourselves a bunch of hassles by modeling the structure. And so even if your structural engineer isn't providing 3D modeling of the structure, generally speaking, for coordination purposes, it's still a good idea to do so. Now, we don't model every single joist unless they're exposed, but we do model the major structure. And out here in the drive-through showroom, of course, when you look up at the ceiling, you see these joists, and as you can see, there's not very many. So it wasn't a big deal for us to model all this up. So probably all told, to model this structure, you're not even looking at half a day's work. So definitely a worthwhile endeavor. So let's look at the different tool sets that are here for the structural engineer. Now, in times past, engineers did model structure. Now, not so much for visualization purposes as we see here, but more for analysis. And what I want to show you is what you would often see in those programs, those structural engineering programs, when they were doing their modeling. I'm going to switch the level of detail here to course. Now, actually here, I need to do that with my categories. Just give me a moment here. Okay, you folks can see that all of the structural columns and beams are now presenting themselves as a single line. So often when structural engineers are drawing or doing their plans, their plans often will not show the actual physical size of the member. They will just use a heavy, solid line for that presentation. And during the modeling process, if structural engineers in the past were going to send their model to an analysis program, often those programs didn't model the structure either. So what this does is it kind of unifies the modeling process for the structural engineering community. So just like you folks might have used SketchUp and AutoCAD to do your 2D and 3D, the engineers had AutoCAD for doing the drafting and another program for doing their structural modeling. So now for them, the structural modeling and the drafting, the construction document process, can now be integrated into Revit, just like it was for architects. Now, if you show structure in a medium or fine level of detail, then you actually do see the physical size of the members. Now, the difference between medium and fine is only noticeable with certain kinds of structural objects. If you folks look at these open web steel joists, you'll notice that when I go from medium to fine, that it actually shows the physical size of the webs. So at medium, you do see the physical extent of the members, and then at fine, you see them in greater physicality. Now, there's more to this even. In plan, if we look at a W-shaped beam or an HSS tube, now let me just turn the line weights off here. Now look at this HSS tube. Now you guys know that HSS tubes are radiused at the corners. Now, one of the things that you can do, and I'll mention this as a tip later, is that your structural categories, you can ask Revit to show these structural categories, your columns and your joists, you can force them to show at a medium or fine level of detail. So even if your overall plan is at a scale that warrants the use of the coarse level of detail, you may still want your structural objects to show with a degree of realism, so you may override them to show them as medium, as I have done here. What I want to show you, just like you saw with the joists between medium and fine, is what happens with these columns between medium and fine. So here's the fine level of detail now. So now you're seeing the radiuses on, or the radii on these HSS tubes. What's going on? What's being modeled here? Well, at the medium and fine level of details, there are actually two solids inside this column. There's a solid with the radius in it, and there's another solid that just has it mitered to a 90-degree corner. And you're like, really? Really, why? I don't know exactly. I guess the developers just decided that for optimization purposes, showing these actual curves wasn't going to happen until you switch your level of detail to fine. So just be aware of the differences between coarse, medium, and fine, and how they display on your screen, and that you can, in any given view, override the level of detail for any category. So for my structural categories here, I'll often switch them to the medium level of detail for my working drawings. And you can see now it's going to switch back to 90-degree corners. At the coarse level of detail, by the way, your columns are no longer being modeled. Revit just shows a 2D line at the extent of the column. So theoretically, there's a performance improvement that you get from that, but our computers are so powerful, to me it's like, what's the point? This is a feature that was baked into Revit years ago when we had to model buildings using a Pentium 3. Now that computers have come a long way since then, I would say that this feature is obsolete. So I will always show my structure at the medium level of detail. So the structural tools that are provided, you've got beams, columns, and beam systems, plus your foundation tools. Now I am not going to get into any of these rebar tools. That's beyond the scope of this course. If you're an architect who needs to model the engineer's structure for coordination purposes, rebar is not your gig. Just stick to showing the columns and beams. So that's what we're going to focus on tonight. Now there's a certain strategy or order of operations to creating structure. So if you folks look under the structural tool set, we talk about creating columns first. So you put your columns in, and then beams, and then beam systems. Now, I'll show you why in a few moments, but that order is kind of analogous to how we do our buildings in Revit. We start with the walls first, right? We draw the walls for our plans, and then we add floors and roofs. And as our exterior walls change their location, our floors and roofs change their size to suit. Okay, the bottom of page 1, we've talked a little bit about the difference between structural and architectural drawings. Structural drawings show the structure supporting the floor that you're looking at, and architectural drawings will show the structure above or within the room that you are standing upon. We talked about the simple heavy line, and we will, like I said, we'll often override the level of detail in a view. So you go into your visibility dialog box, just like I was showing you, and go down to the structural categories, pick the first structural category, shift click the last structural category, so that you can override all of these categories at once, so that you don't have that super simplified presentation of structural objects in your views. Point number 3 at the bottom of the page there, we talked about how structural columns, when you draw them, will tend to draw downwards, and architects will draw the columns upwards. So when you start using the structural column tool, the very first thing you need to do is switch from depth to height when you're putting in that column, so it goes upwards in your plan instead of downwards. Another aspect with modeling structure is how multi-story structure will be drawn. So if you have a residential tower of multiple stories, many of you I'm sure have worked on such projects, what happens is you'll have a column of a certain size at a lower story, and as you get up to the higher stories, that column gets smaller and smaller, or thinner, or changes shape as you go from one story to the next. Now, if a column is of a certain size for 10 stories, model it as one column. That's 10 stories tall. It's easier for you if you have to move that column around in your parkade to get the parking layout to work. Move it around, and then that column for the next 10 stories up is going to be in a different place in your plan, and you won't have to truck through all the plans and relocate that column. So model it as the same story. Now the problem, of course, is that structurally speaking, when you have all of your different floors, that column is traversing through all of those stories, but really the engineer would tell you that there's a moment connection at each slab where the column impacts it, so that when there's a seismic event, the column wants to rock individually, it It's not a solid element all the way up. So a structural engineer would model this as a series of separate columns. Doesn't matter to us architects, we just want to make the plan work. So the engineers will, in Revit, model that as a single column for each story. And in fact, there's a function in Revit that when an engineer imports the architect's column, the column can be split on a per story basis. So Revit structure has that already built in because the software anticipates that architects aren't going to bother with modeling, you know, the same size column on a single story basis. It's a waste of our time. All right, so let's move over to the next page here. Now I am going to start a blank architectural project, and I recommend that you folks do the same. So I'm going to start a new project here. Now what I would recommend that we all do is create a set of grids in each direction. So just draw 3 or 4 grids in each direction so we can talk about how the structural column tool works in conjunction with your grids. Structural columns are often put at grid lines and at grid line intersections. So, when we are using the structural column tool, there is an at grids option. So if you click on the at grids option, you can see the Revit interface changes a bit, and it's giving us this situation. So if you look on the status bar, it says select grid lines to place structural columns at intersections. So if I just select a couple of grids, have a look. So first of all, before you even get started here, you have to choose the column type that you want used at all these grid line intersections. So if this W10 by 49 isn't the right size, you want to preload that column before you get started. So no big deal there. So if you crossing select all of the columns, you can see now that if you hit finish, you get columns at all of those intersections. So when you look in 3D, there's your column layout, placed at all of the grid intersections. Now I'm just going to undo that step and talk about some other aspects of the column placement. So if you're using the structural column tool, you can, of course, you don't have to place it at a grid, you can place it anywhere. When you hit the space bar, it rotates at 90 degrees. If you put it on a grid, it rotates at 90 degrees. But if you place it at a grid line intersection, it rotates it through 45 degrees. Now, why is this? Well, it's quite common in steel construction for 45-degree angle grids to be put in place. This is something that's commonly done in steel construction to prevent or to resist lateral loads and to deal with diagonal bracing in a floor diaphragm. So that's done in steel construction. And of course, steel construction is probably more common in the States than it is here. So that bit of functionality there where you can hit the space bar and it rotates the column through 45-degree angles, that's where that feature comes from. So just hit the space bar when you're at a grid line intersection and it rotates the column around. Now, you'll also notice on the Place Column tab that you could place a structural column at a pre-existing architectural column location. So if you have some architectural columns that are already in the view, you can hit the Add Columns button and it'll place structural columns at locations where architectural columns can be found. Finally, there is a slanted column option. So normally your columns are vertical, but if you choose the slanted option, then what Revit shows you, first click, what is the elevation of the first click? So in this case, it would be level 1 minus 9 feet. Second click, I can choose which story it's associated with. So if I wanted to go from level 1 to level 2, what will happen now is the first click, the column will be at level 1, and the second click, the top will be at level 2. So whatever horizontal distance I indicate on my screen, that will be the deviation, the horizontal deviation between the bottom and top of the column. So I'm just going to place this in here now. And if I go back and look at it in 3D, there's my column. Now just to give us some context here, I'll go back to my level 1 plan and I will put in some columns here, vertical ones, just in these other locations, just so you can see what I started with there. So there's the 3 vertical columns and the 1 sloped column. You mean like trim it at the top so it's cut off?
No, if we want to be 3 degrees or 90 degrees.
Oh, okay. So the question is, how can you place a column at a specific angle? That's a good question. So what I'm going to do is I want to have my column, so this column here that I'm placing, I want to put a column on here at this grid intersection at a 45-degree angle and leaning out at a 10-degree angle. So how would I do that? So number one is we would put in a reference plane. So reference planes are really handy when you want to put geometry at a certain location, especially if you need to draw it on an angle. So what I'm going to do is I'm going to draw a reference plane here from this grid line intersection, just going out at a 45-degree angle. So I'm looking for 135. There it is. So I've got this reference plane sitting here. And now what I'm going to do is I'm going to name that reference plane. So after you put in a reference plane, you can name it. And you'll see why we do this in a moment. So I've called this reference plane sloped column. Now what I need to do is create a section or an elevation that's looking perpendicularly at this reference plane so I can draw that slanted column on it. Now there's a couple of ways that you can do this. On the architecture tab, you can draw a, on the view tab rather, you can draw a section. And when you draw a section parallel to a reference plane, it will snap to it. So Revit kind of pays attention to the location of those reference planes. So that's one way. You could draw a section, or you could draw an elevation, I believe. That we'll see. No, it's not going to see it. We're going to use the framing elevation here. View, elevation, framing elevation. Now look at this. When on the View tab, you use the elevation tool, there's a drop-down menu. I'm sure you folks have used the standard elevation tool frequently. We're going to look at the framing elevation tool. Now when you use the framing elevation tool, it will automatically snap to and pay attention to grid lines and reference planes. So now what we can do is we can create an elevation that is looking perpendicularly at that reference plane. So there it is. So now the next step is to open this elevation view, Just by double clicking on the pointer. And there's my elevation. Now, how do I know where I'm starting from? Right? I've got my two levels here, but I can't see where I'm starting from. So again, I need another reference plane to show that I'm starting from here. So on the Architecture tab, I'll grab the reference plane tool again, and I'm going to draw another reference plane perpendicular to the first one. So I need to do this so that in that elevation, which is looking perpendicularly at the placement plane for our column, we can see where the starting point is with that other reference plane. I don't need to name this next one. It's just going to be there as a reference when I look in plan, or when I look in my framing elevation. So I will return now to the framing elevation. So there is the starting point for my beam. Now, remember that I named that other reference plane, and here's why. In this view, I want to draw that column on an angle on that reference plane, right? So on this reference plane right here, this one. And I named it sloped column. So when I return to my elevation, what I'm going to do now is I'm going to use the set work plane command. We're going to be using this command quite a bit over the next few weeks, set work plane. And out of the name drop down at the top, it'll show you all your grids and all your levels and any reference plane that's been given a name. So you can see it's in the list here. So with this reference plane named, and I can choose it out of the set work plane command on the Architecture tab and hit OK. So now whatever modeling I do, it will be placed on that plane. So now when I use the Structure tab, column command, you can see I don't even have an option for a vertical column. Revit says you're probably in the mood to do a sloped column here. And so we start here at this intersection, and we can draw it at any angle that we want. So if I want to do that 10-degree angle, or 20-degree angle, so here it is, I can draw it and make it so it goes up to the second floor. Now again, fine level of detail, if I switch to medium or fine, then I get to see the actual physical size of this column. So now we have that column angled out on the slope that we want. Now again, pay attention here. When I switch from the medium to the fine level of detail, look what happens to my W-shaped beam here. It actually will show the curved fillets. So maybe for rendering purposes, you may want to show the curves there. If the camera's long distance away, it doesn't matter. It's up to you what you want to do with that level of detail. Okay, so let's take just a 5-minute break here. If you guys want to use the washroom, or go downstairs and grab a coffee, and we will get started right after that.